Hey guys, welcome to another video. Today I'm going to be making an AP Stats FRQ video. Just one FRQ from the 2017 AP Stats exam. This one is going to be about linear regression, and it is going to be FRQ number 1 on the 2017 exam. To start us off, I made a little meme for us. It says you always reject the null hypothesis if your significance level is 1.1, not 1.1%, just to get that clear, 1.1. So, if you think that's funny, your choice. Either way, memes aside, let's begin with this problem. So, researchers studying a pack of gray wolves in North America collected data on the length x in meters from the nose to the tip of the tail and the weight y in kilograms of the wolves. A scatter plot of weight versus length revealed a relationship between the two variables described as positive, linear, and strong. So I'm going to write down some of the key terms that are in this question and worth remembering before I even get to part A, B, or C. So first things first, this is a linear regression problem. So knowing what x and y are important. Now you might be asking, if I just know that there's x and y, why do I need to know what they are? Well, first of all, context. Context is very important on the AP Stats exam, and especially on the FRQs, which on the 2020 exam, it's going to be only FRQ, and so it's very important that you include context. Context is something that can get you a lot of points if you do it right. It's not very hard, you just need to read the question to do it, or you can lose points if you don't add it at all. So do add your context, do make sure that you're putting in context. So x is length of the wolf. And this bit more over here, and y is going to be the weight of the wolf. And you could include units. I'm not, because I just want you guys to be able to see, but length is in meters, weight is in kilograms. So what information did they give us? So specifically, they gave us that the scatter plot, there's a scatter plot apparently. They didn't give us a picture of the scatter plot. I would have put it here, but they did tell us it was positive, linear, uppercase, and strong. So positive, if you remember from when you did linear regression, by the way, this is not about linear regression inference. It is something that I specifically chose because it's not going to be on the exam. There's no linear regression inference in this question. So you're not going to be inferring anything. There's no null hypothesis, despite the meme that I put at the beginning. No null hypothesis, alternate hypothesis, inferring anything. We're not inferring anything, so don't worry about that. So positive, meaning that it is, so positive for starters is the direction of the scatter plot. When it's linear, it's going to be the form, the shape that it takes, basically. And strong is going to be a description of strength. How strong is this graph? How close are the points of the scatter plot to the linear regression line? So identifying those can help you answer part A, parts 1, 2, 3. So in doing that, let's see if we can answer them. So let's do part A. part 1. So I'm going to move this up here. Sorry that it blocks the wolf. But so let's try answering this. So it asks for, basically, if you read it, it's saying, for the situation described above, explain what is meant by each of the following words. And part 1 says positive. So we're going to start with that. And basically what this question is saying, in a more simplified version, explain in context what is positive. So basically what we would say is, this, by the way, I'm going to answer it first out of context, then I'm going to insert context into it. And I'll show what that means if you didn't understand. So basically, the definition of positive is, as x increases, y increases. So that's our basic definition of what positive is. Now, this is obviously out of context. You don't know that this is about length versus height of wool. So we would just replace what we had originally with x. We'd say height. Sorry, I am so sorry. Length. As length increases, I'm going to move this down here. Weight increases. And you could say weight of the wolf. That might be better if you are on a time crunch. This is probably good enough. But if you want to say as length of the wolf increases, weight of the wolf increases, that is completely fair too. Sorry for the pause there. So this is a pretty acceptable answer for a part 1. Now moving on to part 2, it talks about linear. And they basically do the same thing, in context obviously, for linear. What does linear mean? I'm gonna ask you this time, try and define what linear means in terms of regression by yourself, and then I'll give you some time. Do that. Assuming you've given it a go, linear, what it means is, linear means that as x changes by a constant value, y changes by a constant value. And you could actually, I think it would be better to just say as x changes. Sorry for adding all that extra stuff. But that would be a good enough if we were considering out of context. But however, this is in AP Stats FRQ where we need to add context if you want to get full points. So for x, we can replace it with length of the wolf, if you want to say. You could say y as weight. I'm going to move it back on screen. Weight changes by a constant value. And if you think about it intuitively, that's what a linear graph is. If you draw just any linear graph here, I know that's not the best, most straight version of a graph, but if it's linear, it's generally going to increase consistently. Alright, nothing is going to be changing too fast or too slow. So basically, it's saying that y is going to keep on changing by a constant value. So as that's happening, sorry for the pause. And now that you have linear, we can try to define for strong now. Now, what does it mean by when we say strong? Strong basically means that the points of the scatter plot are, put this down here, are close to the line of best fit. So that's the basic definition of strong. Line of best fit of length vs weight would be a good way to implement context, because as I've mentioned a few times, also by the way, this is part 3, line of best fit of length vs weight, that would be a good way to implement context. Context, as I've said quite a few times this video, it's quite important for an AP Stats FRQ. So putting that aside, so open a new text box, and here we're going to start doing part B. So part B is, and before we start doing part B, they give us a little line here. Y is equal to minus 16. By the way, y hat, if you see right here, if you see y hat right here, I put a little red marker there. That represents y predicted. That little hat on top, we call it hat sometimes. I'm sure there's a more formal term for it, but it basically means predicted. When you see that hat, it means that the value is a prediction. And if you think about it, that's what the line of best fit is. Your x values are data points that you got, and y is it, in your line of best fit tries to determine it. It may not be accurate, but it's a prediction, and so that's why we put y hat on top and not just y in AP Stats. So, and in statistics in general. For B, we want to interpret the meaning of the slope. Take a second, try to find out what the slope is in the equation. So if you said 35.02, you would be correct. Now, why, you might be asking, why isn't it negative 16.46? That's actually the y-intercept. So 35.02 is the slope. You might have also, another clue that you might have noticed, it said that the scatter plot was described as positive. Negative 16.46 is negative, and 35.02 is positive. So, you know, I don't know how else to describe it. It's kind of obvious there. So 35.02, that is the slope in this case. So it says to interpret the meaning of the slope. So just writing down the slope doesn't help. But 35.02, the slope, represents the, so take a moment, try to find out what it represents. So represents the increase in y for every increase by 1 in x. So every time x increases by 1, y is going to increase by 35.02. Basically saying that every time the length of a wolf increases by 1 meter, the wolf, as predicted, will increase by 35.02. That's the prediction, that's the slope in this case, what it means. Now y and x are out of context. So what does y mean? The weight. So 35.02. If you want to put sorry, not 30. And you would also want to put length, meters. And also, when you do an AP Stats FRQ, read your sentence and see if it makes sense. If a wolf increased in length by 1 meter, is 35.02 kilograms, a reasonable amount to grow by? Maybe if someone misread this, and here's maybe a potential mistake. Let's say somebody read it every 1 inch, but they read kilograms as well. So maybe they might see that, oh wow, every time a wolf increases by 1 inch, it's increasing by 35 kilograms? That's completely unreasonable, and then they try to scramble about for another answer. Turns out that their assumption is correct, except for the meters, inches thing. If you didn't understand, basically, I'm just saying, like, it's a potential mistake that you can get by misreading the question. So be sure, read the question carefully. So that would be a acceptable answer. Maybe you'd want to include the words wolf, length of the wolf, weight of the wolf, kilograms potentially. Maybe I'll do that right here. So now that that's out of the way, C. By the way, for the previous problem, you might notice I wrote 35.02. You do not need to. It just says interpret the meaning of the slope. If it says identify the slope, then you'd need to put it. But obviously, just for kicks, I added it. So C. One wolf in the pack with a length of 1.4 meters. So they're giving us a coordinate here. So let's get the information from here. 1.4 meters is x. Had a residual. Now, what is a residual? I'm hoping that you've heard this in your AP Stats class before. But let's say we have a scatter plot with a bunch of points. I'm not going to draw all the points. I'm going to draw one point in specific. Let's say we have a point here. And this is your line of best fit. The distance from there is your residual. So basically you take the y, this is the actual y value. This is a data point that you saw in the wild. In this case it would be in the wild. And here is y predicted. This is what you predicted using your line of best fit, y hat. Your residual, which I'll demarcate as r for our purposes, and this is going to be equal to y. So the actual minus the predicted. Not the best drawing of y hat, but hopefully you got it. So this is the residual equation, and if we go here, sorry for the dot here. Alright, so if we now try to find the residual, it's saying that it has a residual of negative 9.67. So what was the weight of the wolf? So what they're asking for us here, I'm going to move over here. Let's make a table of what we know. So we know x is 1.4. We don't know y. This is actually what we're trying to find. So I'll demarcate F for find. We also have y predicted. So we can use that too. We also have this linear regression line, and it applies to part C as well. So using it, since we know what x is, we can determine y hat. We also know what the residual is because they gave it to us, negative 9.67. Now that we have that, we can, so first things first, since we know what this is, we can find this. We should be able to find the actual value of y. Now, if we plug in, we need to find y predicted first. So to find that, what we could do is plug it into this equation right here. So if we put it in, right, and this should, if done right, give us a answer for, and you can see I was generating the meme earlier, and I have the tabs open for statistics too. Yeah, I don't care. Okay, so we can put in 35.02 times 1.4 minus, if we go back, 16.46. Sorry about that. And this is our y value, or y predicted at least. You can see our GoFundMe page there too. Do check it out. So to add on here, y predicted. So if I remember, 32.57. I'll just round up. 32.57, and we have y f here. Now how do we find this value? Because this is eventually what we need to find. We didn't want to find y hat, but we needed to, because we can use the residual equation, which I'm pointing to for a third time. We can use the y hat and the residual and solve for y. So we got negative 9.67 is equal to y minus 32.57. So you can do negative 9.67 plus 32.57. I'm so sorry. Negative 9.67 plus 32.57 and 22.9 kilograms is y hat, and that is also the amount of kilograms that this wolf weighed. Right here. So the actual coordinate would look something like this. But they didn't want the actual coordinate. What they wanted, let me erase some stuff here, get some space back. You can just play back if you want to see my work again. And if you want to do a little drum roll, you can get the weight of the wolf to be 22.9 kilograms. I'm going to put that in a text box, make that look a bit nicer. So part C, we are going to have the wolf weighed 22.9 kilograms. And that should be good enough. I do want you guys to do one thing for me though. I do want you guys to leave some feedback. This is my first AP Stats FRQ video. I do hope that you guys leave some feedback for me. It would be greatly appreciated, since this is one of my early videos. I know I'm a little nervous. I'm a little camera shy. Not really with a camera, but even my voice, I'm just a little shy. But I hope you guys understand. Please leave feedback. If you guys want to see more of this, comment down below. Thanks.